Hello and welcome back to another video. Here we are going to solve another past year paper of Probability and Statistics 1. It is from May-June 2020. It is 9709 and component is 51. So in this video we will solve the first 4 questions. Let's start with the question number 1. Here's the question number 1. The score when two fair 6-sided dice are thrown is the sum of two numbers on the upper faces. That is the score. Show that the probability that the score is 4 is 1 over 12. So the probability means favorable case upon total case, and here the case is like when the score is 4, it means sum of the two numbers should be 4, and the possibilities for that would be if on the first dice it is 1 and on the second die it is 3, or on the first die it is 3 and the second die it is 1, or on the first and second both die it is 2, then only the sum would be 4. In these only 3 cases we are going to get 4 everywhere. So the required probability P is going to be 3 over, because 1 2 3 over total, that is going to be 6 into 6, 36, because there are two fair 6-sided dice, so it is going to be 1 over 12. So that's the probability of getting the score is 4. Now in the second part, the two dice are thrown repeatedly until a score of 4 is obtained. So it is going to be a geometric distribution, because all the attempts are independent of each other, one another, and the probability of the score is remaining same here everywhere. So the number of throws, the next is the number of throws taken is denoted by the random variable x. Find the mean of x. So first of all, we require for the geometric distribution, the parameter is the probability of success, and the probability of success means probability of getting a score of 4, which is given as 1 over 12 from the first part only. So it is going to, this random variable x is going to be geometric with parameter 1 over 12, and mean of x is expectation of x, and in the geometric distribution the expectation is 1 over p, so it becomes 1 over 12, that is 12. I hope it is okay. Let's do the next part of this question. So here's the C part. Find the probability that a score of 4 is first obtained on the 6th throw. So it says that on the 6th throw it is being the score was 4. It means in the geometric it is like first 5 throws was not in the first 5 throws the score was not 4, so it means not means 1 minus 1 over 12 power 5, and on the 6th throw it came the score become 4, so it means it is a success. So 1 over 12 6th time, so it is 11 over 12 over power 5 into 1 over 12, and when we'll calculate, so this is 0.0539, so it is going to be 0.0539 only. And in the D part, find P of probability of x less than 8. So if it is x is less than 8, the number of throws required to get the first success as 4, like getting a score of 4 is less than 8. So what we are going to do, we cannot calculate, because it is like it can be on the first throw or on the second throw or on the third throw. So the better way to calculate is like calculating the probability that it requires at least 7 attempts to, or 7 throws to get the first success, and then we will subtract it from 1. So it is indirectly will be giving the value of probability of x less than 8. So this is going to be 1 minus, and in the geometric again it is probability of x is greater than or equal to 7. It means on the first 7th rows it was not success, means 11 over 12. So this become 1 minus, this is 0.54385, 1 and all, and then 1 minus this, it is a final answer, that is 0.4561, so it is 456. So these are the two probability, that's the answer. Let's do the next part. Here is the second question. First part, find the number of different arrangements that can be made from 9 letters of the word jewelry, in which 3 E's are together and the 2 L's are together. We know that in these 3 E's they all are similar and 2 L are also similar, and the condition, another condition is they should be together. If it is given that they should be together, we can take them as one. So we can take these 3 E's as one quantity and then 2L also as one quantity, because they should be together, and remaining 4 like of different arrangement by these letters. So there are going to be 1, 2, 3, 4, 5, 6 numbers. So the total number of different arrangements, the number of different arrangement means we are going to simply arrange these numbers, these letters, collecting 3 E's as 1 and collecting 2 L's as 1. So it becomes 6 factorial only. And here we are not going to divide by 3 factorial into 2 factorial, because these 3 E's are same. So it's like it does not matter this E comes here or here, because they are going to be same, and the same thing with the L. In case if there are 3 E's marked as E dash, E double dash, and in then E triple dash, then we should have multiplied by 3 factorial, because they can interchange their place. But in this case, since they are same, so we don't have to do anything. So number of different arrangements would be 6 factorial. I hope it is clear. Let's do the B part. B part is find the number of different arrangements that can be made from 9 letters of the word jewelry, in which 2 L's are not next to each other. So it's like if we find the total number of different arrangements, and then we subtract the number of arrangement where 2 L's are coming together. So total number of arrangement minus number of arrangements, with 2 L's together. So total number of arrangements, we can see there are 9 letters, so it would be 9 factorial, and 3 E's are there, so duplicacy we have to divide by 3 factorial here, and similarly for 2 L's, so 2 factorial. And for the case when the 2 L's are coming together, we have to take these 2 L as 1. So they are going to be 1, 2, 3, 4, 5, 6, 7, 8 numbers, so in 8 factorial ways. And again, to remove the duplicacy, we have to divide by 3 factorial, because there are 3 E's, so it is 3 factorial. Now we will calculate this. 30,240, and this value is 6,720. So the answer is the total number of different arrangement would be 23,520. So I hope it is clear. Let's do the next question. Here's question number 3. A company produces small boxes of sweets that contain 5 jellies and 3 chocolates. Jamil chooses 3 sweets at random from a box. Draw up the probability distribution table for the number of jellies that Jamil chooses. So 3 sweets and For the distribution, let's say it is x, number of jellies denoted by x. So we have the possibilities for, it's like no jellies at all, 1 jelly, 2 jellies, or at most 3 jellies, because there are 3 sweets he can choose. Now for the probability distribution table, we need to find the corresponding probability as well. Now for the 0 means no, it is like a binomial question. Binomial, the probability of success, or we can say here probability of getting jellies, is 5 over 5 plus 3, 8. So not getting this is going to be q, and it is going to be 3 over 8. Now here it is 0, and we know that we cannot, it's like taking the 3 sweets, so it means this is not replaceable, so not replacing, so every time it would be reducing. So for the case when the number of jellies is 0, it means all the three times Jamil got chocolate. So for the binomial thing, it is 3C0. For the first chocolate it is 3 over 8. For the second, which is of course not jelly, means all the 3 chocolate sweets are chocolate, so second is, it is going to be 2 over 7 because 1 has been removed, and the last one is again 1 over 6. It's not getting replaced, so every time it is going to be reducing. And then for the 1, so 3C1, one time it is jelly, so 5 over 8, and then second time it should be chocolate, so it is going to be 3 over 7, and for the third it is again chocolate, so it is going to be 2 over 6. Similarly for number of jellies, 2 jellies, it is going to be 3C2, 5 over 8 into 4 over 7 into last 3 over 6 for the chocolate. And for all the 3 to be jellies, it is going to be 3C3, 5 over 8, 4 over 7 because 1 has been removed, and then 3 over 6. We'll simplify it. It is going to be 3 2 just 6, cancelled, 1 over 56 here, and then I should have written it here only. And then next one is 3C1, it is 3, 5, 3 2 just 6, cancelled, and it is going to be 5 over 56 here, and for this again denominator as 56 everywhere. So I hope it is clear. Let's do the second part of this question. The company also produces large boxes of sweets. For any large box, the probability that it contains more jellies than chocolate is 0.64. 10 large boxes are chosen at random. Find the probability that no more than 7 of these boxes contains more jellies than chocolate. So if we take n as 10, and probability of success, we can take x as the number of boxes or for number of large boxes for which more jellies are there than chocolate, then it is probability of success is going to be 0.64. so remember, here we have taken the x because we are going to make it as binomial. So x is number of boxes, number of large boxes contains sweets where jellies are more than chocolates. So it's binomial with parameters 10 and 0.64. And now comes the question, find the probability that no more than 7. No more than 7 means probability of x less than or equal to 7. This is what we need to find. Find the probability that no more than of 7. So x is less than or equal to 7. This is what we need to find, and this can be done in two ways. First one is from 0. We can start from 0 to 7, or another way is we subtract the last remaining part for the 10 large boxes. So it is going to be minus probability of x is equal to 8 plus probability of x is equal to 9 plus probability of x is equal to 10 here, and we subtract it from 1. So we have p, so we can calculate q from here. That is going to be 1 minus p, that is 0.36. so it become 1 minus probability of x is equal to 8. In the binomial it is going to be NCR, that is 10C8, success probability 0.64 to the power 8, and failure probability 0.36 to the power 2. And for 9 it is 10C9, 0.64 to the power 9 and 0.36, plus 10C10, 0.64 to the power 10. So it is 1 minus, we'll calculate this by calculator. So this value is 0.16415, so I'll take it as 2, plus the next value when it is going to be 1, this is going to be 9, power is 9, and here we are going to choose 9. So this value is 0.06485, so till 4 decimal place I'll take this as 9, and plus then last one is 0.64 to the power 10, because 10C10 is 1, is going to be 0.01152, so it is 115. Altogether this value is going to be 0.7594, so 0.759. I hope it is okay. Let's do the next question. So here's the question number 4. In a music competition there are 8 pianists, 4 guitarists and 6 violinists. 7 of these musicians will be selected to go to the final. How many different selections of 7 finalists can be made? It is selection combination. If there must be at least 2 pianists, at least 1 guitarist and more violinists than guitarists. These are the 3 conditions. So for the pianist it is like more than 2, so 2 to 8 we can go, 2 to 7, all 7 we can choose. For guitarist also we can go till 1 to 4 all, and we'll check for all the conditions here. So the first one is like when we have to start, we need to start with one condition. So here and here there are 3 conditions. So first we'll start with the at least 2 pianists. So at least, so let's start with 2 pianists. And now for this 2 pianists, if we are taking 1 guitarist here, 1 guitarist, so we need 7 finalists. So of course the third condition would be satisfied in the way we can choose the number of violinists here, because 2 plus 1 3, so 4 violinists we have to take. First one, if this is satisfied. Next one is if we take 2 pianists only and 2 guitarists we are taking, then for 7 finalists we can choose 3 violinists again. But if we choose 2 pianists and 3 guitarists, so we are only left with 2 finalists, and that cannot be violinist, because my violinist should be greater than guitarist. So this is not the case. Next one is if we are choosing 3 pianists here and 1 guitarist, 3 plus 1 4, so we can choose 3 violinists here. Similarly, if we are taking 3 pianists and 2 guitarists, then 3 to 5, then we have to choose 2 violinists, which is of course not the case, because third one is not satisfying. For the next one, if we are choosing 4 pianists here and 1 guitarist, so 4 1 5, 2 finalists are still left, so we can choose 2 violinists here. that is satisfying. But for the next case, if you choose 4 pianists and 2 guitarists, so of course that would not be satisfying. So these are the only cases which we need to find the selection. These are the only selections for the 7 finalists. So let's select them. First one is 2 pianists, 1 guitarist and 4 violinists. It's like the number of ways would be 2 pianists out of 8, so 8C2, 1 guitarist out of 4, so 4C1, and 4 violinists out of 6, so it is 6C4. Similarly for the next one, 2 pianists, 2 guitarists and 3 violinists, it is going to be 8C2, 4C2 into 6C3. Next one, 3 pianists, 1 guitarist and 3 violinists, so it is going to be 8C3, 4C1 into 6C3. And the last one is 4 pianist, 1 guitarist and 2 violinists, it is going to be 8C4 into 4C1 into 6C2. So we will calculate them all and we'll add them. So first value, it is going to be 1680. Next value, 8C2 into 4C2 into 6C3 is 3360, 4480, and the last one is 4200. So the total number of arrangement, the final answer, total number of different selections would be 000. So 0, 8, 6, 14 plus 8, 22, 4, 4, 8, 8, 6 to 14, 14 plus 3, 17, 5, 4, 9, 10, 13. So it is going to be 13,720 different selections of 7 finalists. So that's it. I hope it was of some help. So let's meet in the next video with the last few questions. Thank you so much.